Hey everybody, welcome back to Spark Rise. In this video, we're going to be breaking down one of the most fundamental concepts in computing and a really key component of your GCSE computer science. Just a reminder, this is appropriate for all GCSEs, preferably OCR, but this should apply to anyone. It's also a great refresher if you're looking at doing your A-level in computer science, or even if you're studying undergraduate computer science. It is the core concepts of the fetch, decode, execute cycle. This cycle is what allows the CPU to process instructions and carry out tasks, and it happens billions of times per second in all modern day computers. Let's take a closer look at how it works, and whilst we get into the video, if you just drop a like, comment and subscribe, that would help massively. We've got loads more videos like this on our page, including past paper walkthroughs and loads more content covering videos like this, loads of shorts going over key fast snippets of content, so please go and check them out after you finish watching this. We're looking to be running some live streams soon as well, so hopefully you can come along and join them when we're getting close to the GCSE and A-level period. But let's get into the video. So the fetch, decode, execute cycle is a continuous process that a computer follows to retrieve, interpret and execute instructions. Every single action performed by a computer, from opening an application to performing a calculation, is carried out through the cycle. The cycle consists of three main stages: fetch, decode, and execute. Let's break each step down in more detail. The first step is fetch, where the CPU retrieves an instruction from memory. Here's how it works. The memory address stored in the PC is copied to the MAR. The program counter, or PC, is incremented by 1, pointed to the address of the next instruction. The instructional data at that location is sent to the MDR, or memory data register. The instruction or data in the MDR is then ready to be processed and ready to move on to the next step. So let's just go over that again. So the memory address is stored in the PC. So the PC holds the value of the next instruction to be processed. So that value in there is then copied to the memory address register to tell us where we need to search for. PC is incremented to point to the next address to search for. The address stored in the memory address register is then used to retrieve the data from the memory data to store in the memory data register. So then you've got your data in the memory data register. This data, or it might be an instruction, is then processed or is then ready to be processed. And there's a register called the current instruction register, which you go into more detail at A-level, which is where it's held whilst it's being processed. And the second stage is decode. Here, the control unit examines the instructions stored in the CIR to determine what actions need to be performed. The instruction is broken down into its components so that the CPU understands which operation is required. If the instruction involves arithmetic or logical operations, it is passed to the ALU, which is where all our maths, all our and or not, greater than, less than operations are carried out. Once the CPU understands the instruction, it moves on to the final stage, which is execution. The execute stage is where the CPU carries out the instruction. Depending on the type of instruction, different actions may occur. If the instruction involves a calculation, the ALU performs the operation, storing the result in the accumulator, or ACC. If the instruction requires storing data into memory, the memory address is placed in the MAR and the data is transferred to the MDR. Once the execution is complete, the CPU moves back to the fetch stage and the entire cycle repeats. It repeats continuously, processing billions of instructions per second. This is a really key point you need to make when you're sitting your exams. That normally a fetch, decode, execute cycle question is 4 marks. You've got fetch, it fetches the instruction from memory; decode, the instruction is decoded; execute, instruction is executed roughly, and then you need to say for the 4th mark, and the cycle repeats. That's really important. This is going into a lot more detail than you probably do need to know for your exams, but it's great to know this knowledge, especially if you're looking at A-level and bachelor's in computer science. But the most important thing is just to go back through the video, understand that fetching is about getting the address, getting the data or instruction. decoding is looking at the data or instruction and actually understanding what it's asking, and then executing is about carrying out the instruction on the data. So to recap, the fetch, decode, execute cycle allows a CPU to process instructions in the three main steps. The cycle is the foundation of how all modern computers operate, and understanding it is essential for everyone studying computer science, as I said. I hope you found this breakdown helpful. If you did, don't forget to like, subscribe, and leave a comment below with any questions. Thanks for watching, and I'll see you in the next one.